Yeah, hello everyone. Hi, Professor. Today we are going to give the presentation on the Advanced Artificial Intelligence course. Myself, Vamsi, and my teammates, Siddhartha Kapati and Sivasai Krishna. Yeah, today we are going to present the two papers. The first paper is a roadmap of agent research and development, and the second paper is multi-agent planning for engineers. Coming to the first paper, we are going to discuss on abstract research and development activities in the field of autonomous agents and multi-agents are summarized into this publication. Its goal is to identify significant concepts and application, as well as the relationship between them. The field of the agent-based computing is given some historical context, and analyzing, designing, and implementing complex system softwares are done in this paper, and the directions are given. Finally, a number of unsolved concerns and potential future challenges are discussed. Coming to the autonomous agents, the goal of this section is to identify numerous lines of study that have led to the current research and development in the agent-based system, and the advances in the autonomous agents fields history and prehistory up to including present systems. Some of them are artificial intelligence. Like artificial intelligence, without a doubt, the most important contributor to the field of autonomous agents. Finally, AI is about creating intelligent objects, and these aircrafts can be termed intelligent if they sense and behave in a specific context. And the object-oriented programming. It is the fundamental case of seemingly odd situation was that previously. And during this time, AI planning was the most closely related area of the research that are autonomous agents. And the object-oriented programming frequently overlooked the concepts of agent as being novel. This is perhaps unsurprisingly when one considers the relative qualities of the agents and objects, why they are clear. And the third one is computer-human interface design. When we utilize a user interface to engage with a computer, we are now using an interface paradigm called as direct manipulation. And the issues and future directions. Within the agent field, the issue of the agent architecture, particularly layered or hybrid architectures and practical reasoning architectures, continues to be the focus of great research. Coming to the second main part of this paper is multi-agent systems. Coming to the history of this, traditionally research into the multi-agent systems has been conducted under the umbrella of distributed artificial intelligence, which has been divided into two groups: distributed problem solving and multi-agent systems. More recently, the phrase multi-agent system has taken on a border, and now it is used to refer any system with many autonomous concepts. And some of these in this are actors. It is one of the first models of the multi-agent problem solving was the actors model. Actors were proposed as the universal primitives of the concurrent computations. Actors of the self-contained interactive autonomous components of a computing system that are communicated by the asynchronous message passing. And the second one is task allocation through the contract net portal. The issue of the flexible allocations of the tasks to the multiple problem solvers received attention early on the history of well-known contract net protocol. The next, the distributed vehicle monitoring trust under the blackboards. Coming to the multi-agent system, cooperative multi-agent interactions. As interest grows in applications that use cooperative agents working toward a common goal, and as more agents that cooperative as teams are built. And the next one is self-interested multi-agent interactions. And the issues and in the future directions. In order to accomplish their design goals, they must interact with one another in such environment. Agents who want to coordinate with another. For example, when it comes to cooperating or negotiating, there are two key obstacles to overcome. And the applications are some of the applications are key domains and exemplar systems. And in industrial applications, they are manufacturing, process control, and telecommunication. Air traffic control, transportation systems are some of the industrial applications. Coming to the commercial applications, those are information management, business process management. Coming to the entertainment applications, they are games, interactive theater, and cinema. And rest of the applications will be explained by my teammate Siddhartha Kapati.
Hi, my name is Siddhartha Kaparthi. Here I'm going to explain about applications. Agent technology is increasingly breaking out of the colleges and research lab and finding its way into a variety of industrial and commercial applications to solve real world challenges. Today, there are fielded applications and the new systems are being created at an accelerating rate. The objective of this section is dual in light of this context. Key domain and explainer systems, manufacturing, process control, telecommunication systems, air traffic control, traffic and transportation management, information filtering and gathering, electronic commerce, business process management, entertainment, and medical care are the main areas in which agent based applications have been reported to date. While it is beyond the scope of this paper to review all the systems in all of these domains, we will attempt to detail some of the most important systems in this area. Industrial application of agent technology were among the first to be developed, and today agents are being applied in a wide range of industrial system: manufacturing, process control, telecommunication, air traffic control, traffic and transportation management, information filtering and gathering, electronic commerce, business process management, entertainment, and medical care are the main areas in which agent based applications have been reported to date. While it beyond the scope of this paper to review all the systems in all of these domains, we will attempt to detail some of the important systems in this area. Commercial applications. While industrial applications tend to be a highly complex the scope system which operate in comparatively small niche area, commercial applications, especially those concerned with information management, tend to be oriented much more towards the mass market. Entertainment application. The computer science community frequently overlooks the leisure business. Leisure applications are typically viewed as auxiliary to computer seriously users. However, recreational applications such as computer gaming can be both demanding and profitable. Games. Grant and Cliff used agent techniques to create the hugely successful creature games. Creatures offers a rich simulated environment with a variety of synthetic agents with which the user can engage in real time. The agents are supposed to be sophisticated dogs whose growth is influenced by their encounter throughout their lives, etc. Interactive theater and cinema. By interactive theater and cinema, we mean a system that allows a user to play a role in a play or film that is similar to that portrayed by actual human performance while engaging with artificial computer characters who have real life behavior characteristics. Believable agents, software programmers that give the illusion of life, thereby allowing audience suspicious of disbelief, are often used to play the part of humans in the theater style applications. Here comes the medical applications. Medical information is a major growth area in computer science. New applications are being found from computers every day in the health industry. Patient monitoring. The Guardian system is designed to aid in the management of patient care in the surgical intensive care unit. The system was developed in response to two concerns. First, that the patient care model in a SICU is essentially that of a term in which a group of experts with different areas of expertise collaboration to organize patient health care. And the second, that one of the most important factor is good SICU patient health care is adequate information sharing among critical care team members. Healthcare. In this paper, a respectivity agent-based distributed medical care system is developed. The goal of this system is to integrate the patient management process, which often involves a large number of people. If the specialist validates the idea, a treatment plan for the patient must be established. With agent mapped onto the individuals and pre-assemblable organization engaged in the patient care process, the system provides for a natural portrayal of this process. Future direction. The system discussed above represents the first wave of the agent-based application. They demonstrate the agent-based system are a useful and powerful solution technology. In addition to providing solutions to meet real-world needs, that is the concept of autonomous solver interacting in various ways to achieve individual and system goals is a helpful software engineering abstraction. Here comes the concluding remarks. Autonomous agent and multi-agent system are the thriving and fast-growing research and development sectors. The concept of autonomous agent engaging with one another for their own and collective good is at its foundation. This fundamental conceptual framework has been uh, has become widely accepted in a number of closely related fields, and it provides a natural and strong foundation for analyzing, planning, and implementing a wide range of software solutions. Despite the evident potential, there are a number of fundamental research and development concerns that need to be addressed. As previously started, these difficulties span the whole area of agent, and full potential of agent-based system will only be realized until solid and scalable solutions are developed. The next topic will be explained by my friend Shiva Sai Krishna. Thank you.
Hello everyone, I am Sasai Krishna Paspleti. Now I am going to explain about the paper known as Multi-Agent Learning for Engineers. In this paper, the main question that is focused on was if multi-agent learning is the answer, then what is the question? So in the introduction part, it has three agendas. One is predictive agenda, descriptive agenda, and engineering agenda. When coming to the descriptive agenda, this will always focus on microeconomic phenomena by following the simple learning path, but it was opposed. So in terms of predictive agenda, it always focuses on the prediction of the future, and the main thing is the engineering agenda. Engineering agenda is always helpful in development of the engineering systems. So let us talk about the importance of multi-agent learning. The important thing when it comes to the multi-agent learning is to build the complex systems with the multiple agents according to the engineering perspective. So the design methodology used in these systems is based on the distributed control. Multi-agent learning helps in building the complex systems with the help of multiple agents. The purpose of designing an optimal system with distributed control systems is most difficult task. So there are a lot of issues like manufacturing issues, routing data networks. Multi-agent can also be used to simplify the complexity of each controller in designing the systems. So when it comes to the tasks, there are some tasks regarding to this paper. No, the first common thing is known as defining the game. Research in multi-learning agent has its basics from the economic game theory called as literature, economic game theory literature. The players, spaces, player utilities, and are also considered under the design considerations. Multi-learning can be better approach for designing a solutions to the problems. The agent's operation in the environment, which changes with the time, is an important task for design methodology that must follow. The type of game can be short, repeated game or an stochastic game. So when comes to Nash equilibrium is based on the behavior of various algorithms. Questions whether converges to the Nash equilibrium or not is decided when the system is designed. In multi-agent learning, significant work is done in limiting the algorithm behaviors. The behavior are then evaluated so that it fits to the Nash equilibrium or to any other target. Nash equilibrium is predictive concept of social interaction. The generality of Nash equilibrium is important for desirable solution. Ideal gaming is not setting up in the multi-agent learning. So performance, convergence, and averages. The behavior of various learning mechanism in terms of limiting equilibrium will work on learning in the games. So the three probable equilibria is known as Nash equilibria, correlated equilibria, and Hassan consistency. These have the limiting equilibriums as well. This helps in assessing the performance in terms of specific domain, specific area, routing in network drives in and routing an algorithm that leads to wardrobe equilibrium. Convergence can lead to the efficiency loss as well. The next task comes is limited information and cost information. Information available to the agent. The most important thing to be considered in multi-agent system and multi-learning is information available to the agent and also the uncoupled learning that leads to the limitation in learning dynamics. Information available is influenced by the specific domain as well. Next slide. Next comes under learning dynamics and bounded equality. There are many adaptation methods growing in multi-agent learning. In descriptive social models, there is an interest in how humans learn the games. So specification of learning dynamics is another great choice for generated systems. Bounded reality for limitations on processing capacity of individual agents. Conclusion. Out of all these parts, engineering agenda is considered as the most efficient and effective methodology for designing the systems, and it is very different from the economic game theory agenda as well. Engineering agenda can be included with the two factors known as robustness and domain knowledge. If we include these two aspects, then we can build a better complex system with the optimal approach, and the optimum multi-learning agents also can be used for building the complex systems. Thank you, everyone. Thank you for Professor for giving us this opportunity. Thank you.